Well, hello and welcome to part 2 of the series on augmented reality. And let's start first of all with a very quick overview of what we are about to do, and then we will start with a quick recap and then we'll get along. We are talking about a series on the augmented reality. So we already covered part 1. Part 1 was more or less theory. Now we are going to head into part 2 over here, which is part 2 and part 3 are both about practice. Now, part 2 is something which we are going to do using a platform called processing, and part 3 is going to be in Unity 3D. Now, as we started, our overall aim is to implement augmented reality in Unity 3D. However, our path, which will start with theory, will first of all pass through processing before we head into Unity 3D. So today we are going to jump into processing, and let me just bring to your information over there. This part 2 might be divided into A and B, as there might be a lot of information which we will not be able to cover in a very short tutorial. So I'll have to split into two parts. We are going to be covering a lot into a very short time. So in all these areas, for example, the details of processing, the details of Unity 3D, rather than going too much into depth, we will be only skimming the surface and move towards our end aim, which is going to be augmented reality in Unity 3D. So without further ado, let's jump into processing and talk a bit about augmented reality. So we need to do a little bit of a recap over there before we can start. Now, augmented reality by definition is when you overlay any information, which could be text or it could be 3D visuals, over a real life world view. Then that is what we typically call as augmented reality. And the way this happens is this world view is generally viewed in a device through a camera. So this camera is seeing the world view. For example, you got a tree or something, so you're seeing this maybe in a mobile device or on your PC/Mac, and suddenly what you do is you add an extra bit of information. For example, say the sun begins to shine. Now the sun is pure digital, but in the end, the user, gets to see a world view superimposed with an added digital view, and in the end you feel your world view has been augmented with some extra bits of information. Makes you a happy person, and this is what we are going to try to achieve over there. And so let's jump into what today's lesson is all about, which is processing. So what is this? So now let's jump into what this processing is all about. Over here, first of all, processing is what is called as an IDE, which means it's an integrated development environment. Pardon my bad handwriting. And it was something which was an outcome of MIT, correct, Massachusetts Institute of Technology, very famed, and it is an integrated development environment which is aimed at quick prototyping of visual snippets of code. So any programming which leads to an outcome which is more or less related to graphic programming or visual programming, processing is something which comes in amazingly handy over there. And how? We'll simply do that with the help of an example, a very quick example. But before that, let's see how to get hold of processing. Now let's jump into the processing website. So go to processing.org and go to downloads, which is somewhere over there. Processing is available for Linux, Mac OS X and Windows. Select your choice below, etc. Now what I would recommend is, please do not go ahead and download the beta. What you should do is go ahead and download the stable release over there. I'm using the version 1.151 for Mac OS X. So once you go ahead and download processing. It should be in your applications folder or wherever you choose to save it. So let's just go ahead and open processing now. There you go, that's processing. We launch processing, an open project initiated by Ben Fry and Casarias from MIT. Now, the moment you open it, you are going to be seeing, please note that it's called the sketch because it is aimed at graphical processing and making visual applications. That is why the code snippet is also, rather than being called a code, is simply called a sketch. So let's start using this, and whatever we are going to do from here onwards, we are going to teach ourselves through this example. Okay, so let's go into processing now. Simply let's start typing over there. I write size. Now you have to understand a bit of programming, so how to write a code, how to write arguments, and how to add that little bit of a semicolon at the end, and we say 640 by 480. So there you go, we wrote the code and we just say run. What happens? There you go. So that's the outcome. What we did was we gave it an argument that please create a window of the size 640 pixels by 480 pixels. Now why 640 pixels by 480 pixels? The reason is, in the end we are going to be taking a lot of video feed from the webcam, and most of the webcam outcome is in the pixel sizes of about 648 by 480 pixels. So the moment you do that, it opens a window, and that's pretty much it. And you stop it and the program stops. Now that's not too exciting. We just popped up a window, but what do we do about it? Fair enough, let's do something. But before we do, bear with me as I increase the code by slightly. So what I'm going to do is, I want this window to open initially, but then the subsequent operations I wish to happen repeatedly. So what I'm going to do is, I'm going to do a void setup, and that's it. So what this means is, I have encapsulated the size opening within a function called setup, which is going to happen only once, and then repeatedly every frame we are going to do what is called a draw function. So what are you going to draw? Let's say we are going to draw an ellipse, ellipse. So ellipse is a function. If you want to know more about what ellipse function does, please go to processing processing references, and over there it'll show you, it has a couple of 2D primitives, some shapes which you need to draw, and over there you have the ellipse, triangle, and so on. So we are going to be using ellipse, which basically takes 4 arguments, which is its location and the dimensions. So let's go back to our processing. We are going to type ellipse. Where do we want this ellipse to draw? We want to draw this ellipse at where our mouse position is, and we want it to be, let's say, 15 pixel by 15 pixels. Fair enough. So far so good. Let's run our sketch. What happens? Aha! Now if I take my mouse and run, whoa, can you see that? Wherever my mouse goes, it is drawing an ellipse. How cool is that? And how long do you think it took us to get over there? Not bad. So, but this is a bit lame. So let's stop this, and we're going to add a couple of things. We do not want it to follow our mouse just like that. What we want is, we want the ellipse to be drawn only when we press our mouse key. So mouse pressed. Let's run it. Let's try something. Aha! So you see, if you don't press, nothing happens. So this is what I would say is very cool. But what's with this stroke which I see at the end? Say I do not want this stroke. So go ahead, stop your sketch and say, simply add a bit of argument, no stroke. Now let's run it once again. Okay, so ta-da, there you go. Let's try something now. Now how cool is that? By simply writing about 5-6 lines of code, you've been able to create almost a mini Photoshop or a Microsoft Paint or GIMP. Over here you've been able to create a window where you can actually paint. Now that is what I would say is the power of processing, for you to be able to write some very cool fast applications at a very fast rate. So I think at this point we need to understand a little bit about processing, what is happening, where it is happening. So let me do this. Let me just take a very quick snapshot of this, and then I am going to explain this to you. See, we first wrote the void setup function. So this function runs only once, which is at the start, and this draw function is something which happens every frame. Now what is this every frame? Well, your computer has a CPU, and the CPU, what it does is it has cycles, which means, and this cycle speed is very high, it could be millions per second, it's gigahertz per second, and every time the cycle runs, this per frame calculation runs. So what happens is, it initially starts by creating this window which is 640 pixels wide and 480 pixels in height, with this point being the 0, 0. So 640 pixels this side, 480 pixels this side. And then every time, every repeated frame, it senses if the mouse is being pressed. Yes, if the mouse is being pressed, then what it says is draw an ellipse, and because of that ellipse is what we've been able to draw this. Back to a bit of theory, and I'll keep on oscillating between theory and practice because that's the best way to go about Innovator. We already took a look at an example and learned how to go about and figure our way around in processing, but now we are going to talk about a little bit of more complicated theory. You see, when we talk about augmented reality, it takes this form. First of all, there is an input, which is a video capture. So this video capture is typically using a webcam, and it takes in the real life form and it feeds into an environment, which in this case is going to be our coding environment, which has to take care of processing the video and display a bit of 3D content and then send it to an output. Now, in our case, our output is simply the screen of our laptop or PC, or in another case, it could be the screen of a mobile phone. Now, what we recently saw was how to write a basic sketch in processing, but now we will try to do a little bit of 3D processing in processing. So let's jump right into our sketch. And now, because we want to do a little bit of 3D programming, what we will do is, you remember we created this initially small window of about 640 by 480 pixels. We are going to now tell processing that yes, we are still going to create a window, but we want processing to be able to handle 3D objects. So we will add an argument which is called P3D, which means processing 3D environment. But also, because we are going to be doing a little bit of a 3D graphics, what we will do is we will go ahead, sketch import library, OpenGL. Our setup function more or less remains the same, but we will change our draw function. We want to say, hey processing, just create a box. Create a box, okay, fair enough. And the box is going to take an argument. If you want to once again take a look at what box function is, what argument is, I recommend that you please go ahead to processing reference. Here it is, 3D primitive box. If you go and take a look at the box function, it will simply create a box. It takes a couple of arguments which are going to be size arguments. So let us go back into processing, and we've given this argument called box. Let's run our sketch and see what happens. So there you go. Once again, a 640 by 480 pixels, and we are seeing something across over there. But what's this supposed to mean? This is not very interesting. I'm seeing just something. It does not even look like a box. Fair enough. Let's see what's missing. Now, you remember in processing, it is the top left corner, which is the coordinate 0 and 0. So what it is doing is, by default, it is making that box at the same location 0 by 0, which is something which we are unable to see. So we need to add a couple of arguments. We do not want it to be in our 0, 0 location. We want it to be in the center location. So we are going to tell the draw argument that whatever you create, please make it by translating it to width by 2 and height by 2. Now if we create or run the sketch, you will see we are seeing a cube which is at the dead center. Fair enough, so far so good, but It looks like a rectangle. How do I know if it is 3D? Fair enough. We shall dispel your doubt in a moment. What we would want to do is we would want it to start rotating. Okay, fair enough. Now, in order to just increment our rotation, we are gonna declare a variable. Let's call it a float I is equal to 0. So far so good. What we want now is to rotate along the y-axis, and the y-axis, the vertical axis, by this variable I. Rotate along the x-axis once again by the same variable I. And in every cycle we want I to be incremented, I plus plus. Let's see what happens now. Whoa, something funky is happening. Something is rotating. Now, what is this? This seems problematic. I'll tell you what the problem is. Let's stop our sketch. Every frame, the background also needs to be re-rendered. So what we are going to do is we are going to add a line. We are going to call it background, and we are going to give it a color. Now you can give any color from 0 to 255. 0 is black, 255 is white, and we are going to give it a grayscale value. So let's just call it about 200. Fair enough. Let's run our sketch. What are we getting? So we are seeing a background, and we have something which is rotating at very fast rate. Hold on. We need to increase, or let's say increment this value by a rather small value. And should we try it now? There you go. Success at last. So what we are seeing now is a 640 by 480 pixel window, at the center of which is width by 2 or height by 2. We are seeing a cube. Now this cube is rotating along the y-axis, which is the vertical axis, and the x-axis, a cube which is a box of size 50 pixels wide, and the rotation rate is simply changing. So ladies and gentlemen, congratulations. You have been able to create a sketch in processing which is making a 3D cube rotate. And how long did it take? Maybe 2-3 minutes or a little bit of a code. So congratulations. Now what we are going to do is, if we take a look at our theory, then this is what I would say our progress is. We've been able to do 3D. We've been able to display an output. So far so good. This part and this part seems to be getting taken care of. Now it is this part and the video editing part. I'm sorry, not the video editing, but the video capture part is what we need to go ahead and capture. So let's start doing that. We will switch over to our processing and we will create a new sketch. Do you want to save changes to the sketch before closing? Yeah, okay, let's go ahead and save that first. Save. And we are gonna call it tutorial processing 3D sketch. Fair enough. Let's go ahead and create a new sketch. The intent of this sketch is going to be to capture video. Fair enough. And in order to do that, once again, we are going to import a library. Let's call it the video library. It has imported the library. Fair enough. So far, so good. Let's get our basics out. We are going to do a void setup. What we are going to do in our void setup is we are going to create a size window. What's the size window? 640 by 480. Very correct. Then we are going to do a draw function. But this is where certain changes need to be implemented. See, this processing video library, it's a class and it is going to instantiate a variable of the type webcam, and we need to declare that. So what I'm going to do over here, I am simply recommending that you just follow it as along, and I'll try to explain as I go along. So you instantiate a variable myCam, which is my webcam, and once the setup is running, you want this myCam to be able to start capturing video, and the argument goes something like this: myCam, which was initiated on top of the type capture. Now this type capture is something which it inherits from the processing video class, and in the setup function, this myCam is going to be made of the type capture with a certain arguments. These arguments are this: width, height, and frame rate 30. Now, when we come to the draw function, what you want to do is you want my cam to start reading from the webcam, and then what you want is this my cam image needs to be displayed at 0 and 0 location. Let's see what happens. What's gonna happen? There you go, voila. Are you gonna seeing yours truly? So what I'm doing is I'm using a PS3 webcam. It is connected to my MacBook Pro. Over here you can also see the setup which I use to generally do these video tutorials. I use a Wacom tablet. This is my notebook where I write my notes, and here the sketch is running, and you can see sketch within the sketch, or cam within the camera, inception, and yours truly. So there you go, you've been successfully able to capture your video camera image and are displaying it in processing. Now over here, although I'm using PS3, you don't need to use the PS3. It will just work on any webcam. Your basic camera will work. Basically, processing is going to search for the first camera, and the first camera is typically the device's own camera. After that, any other external camera which is connected. Because right now I'm doing a video tutorial, so its own cameras have been disabled because the video buffer is going to go into the screen capture. That is why I'm using an external camera, which is also quite good. The reason being, the PlayStation Eye is a fantastic camera, and it's excellent when you want to do image-based processing, what we are going to be needing in our augmented reality tutorial. So let me stop this. So the same is stopped, and here we are. So what did we just do? We were also able to process the input. Now what we need to do is we need to mix these two. So the next step should be, we should start seeing the input video plus some sort of 3D element embedded on top. Okay, let's do that. Let's do save this as tutorial sketch basic video. Let's save that. Okay, now let's try to go ahead and merge the two. Okay, so we're back now. Now over here we have two of our sketches. The first one where we were running our 3D cube, and the second one where we implement our video, and let's try to merge these two. Okay, so let's see what will happen if I simply take these two elements, copy, paste them over here, take this, copy paste here, take this, copy paste it here. Let's get rid of the last sketch. Let's try to run this sketch. Then what happens? Let's see. Whoa, something amazingly funky is taking place. So you see, it is capturing the video, which is right because the image is over on this plane, and it is capturing our 3D cube as well, but our image seems to be running all over the place. Now the reason is this. You see, in the draw function, the first command what it gets is a translation command and a rotation command. So anything which is going to be made after this, including this box and this image, gets the necessary translation, which is to the center, and the rotation. So let me just stop this, and if I take these, cut it and get them on top, then what happens? Let me run it now. Ah, there you go. So what are we seeing over here? Well, we are seeing the basic video which is behind me. Yep, true, that is certainly over there. And we have a cube which is moving on top of it. Now, if you see this cube, its edges are getting clipped. Why is that? The reason is this image is being made in the center of the screen, which has no depth, which is at absolute zero plane. So if I treat this computer screen to be X and Y, then Z axis is inside. So my image is right on the computer screen, and this cube is also rotating right across over there. So there are times when it is trying to go back. So just hold on. What if I give it a slight z value? Let me give it 25. Why 25? Because it is half of the box size. So let me do that, and let's see what do we get. There you go, no clipping. So my image is being drawn on the screen. What image? It is the image which is simply being captured from the webcam, and on top of that a 3D cube is rotating. Let me take a screenshot of this. There you go, done, and stop this. Now we have saved this sketch, and I'm going to upload this sketch so that you can take a look at it. But what you have done is, technically, you have achieve augmented reality. Why? Because you have taken a webcam view of the big bad world out there and augmented that with some sort of 3D graphics. But wait a minute, this is a little bit of lame. I mean, who wants to simply take a look at a 3D cube over there? What we would ideally want is this 3D cube should follow my hand. I mean, it should be in my hand rather than rotating in the center or somewhere over here or across. But that is gonna be what will be the subject of our next video tutorial. We will be using processing, and we will get what will be the secret sauce, which is, now this is where you need to please pay attention. We will import another library, a computer vision library, and our input video is going to be processed by this computer vision library. It is going to check for a pattern which we will print and keep in our hand. It will pass on that pattern's information, and then this 3D element will not be made just somewhere randomly, but it will follow the pattern which we are gonna embed, and that is when we are gonna be doing true augmented reality. So ladies and gentlemen, this brings us to the end of this tutorial, and for true augmented reality we are gonna go to part B of this series. So please work out on the part A of this tutorial, and I will see you next time. Meanwhile, if you have any comments or if you need any more clarifications, please go to my website. It's www.anuragrana.com, and you shall have my details on the about page. You can send me an email or ping me on Facebook, and until then, happy augmented reality. So please go ahead and augment your reality. Take care. Bye bye.